Hey science enthusiasts! Welcome back to another exciting episode where we break down complex scientific concepts into bite-sized, easy-to-digest pieces. Ever wondered how a nuclear fusor works? It's a fascinating device that can achieve nuclear fusion, the same process that powers the sun. Today I'm breaking it down using something everyone's familiar with: vegetables. Yes, you heard that right. We're going to use veggies to make sense of this high-tech marvel. Let's dive in. Imagine we're about to make a delicious salad, but instead of just eating it, we're going to use it to understand nuclear fusion. First up, the outer chamber. Picture a big, hollow vegetable, like a squash. This squash represents the outer chamber of a fusor, a crucial part of the device. This squash represents the outer chamber of a fusor, where ions or atoms stripped of electrons are introduced. These ions are the building blocks of our fusion process. Easy, right? Now, let's move on to the next part. Now inside that squash, imagine a smaller vegetable suspended in the middle. Let's say it's a tomato. This tomato is our inner grid, a key component in the fusor. This tomato is our inner grid. In a real fusor, this grid is negatively charged and pulls positively charged fuel ions toward it, creating a powerful electric field. In a real fusor, this grid is negatively charged and pulls positively charged fuel ions toward it. This electric field is what accelerates the ions to high speeds. Speaking of fuel ions, think of them as tiny peas or beans. These peas are our fuel particles, which in a fusor are typically deuterium or tritium forms of hydrogen. These are the ingredients for our fusion reaction. The peas are propelled towards the tomato. This is similar to how fuel ions are accelerated towards the inner grid in a fusor. As they move, they gain speed and energy. The faster they go, the more energy they have, which is crucial for the fusion process. The magic happens at the very center of the tomato. When enough peas collide with enough energy, a bright spot appears. This is where the fusion reaction takes place, releasing a burst of energy. This is where fusion occurs, releasing energy. In a real fusor, these fuel ions undergo nuclear fusion when they collide at high speeds, producing a significant amount of energy. In a real fusor, these fuel ions undergo nuclear fusion when they collide at high speeds. The goal is for two fuel ions, or Ps, to come together and form a new particle, releasing energy in the process. This is the essence of nuclear fusion. To recap, we have the squash as the outer chamber, the tomato as the inner grid, and Ps as the fuel ions. When we ionize these Ps, it's like shaking them up to give them energy. This energy is what allows them to overcome their natural repulsion and collide. The inner grid or tomato pulls the Ps towards it using an electric field. This field accelerates the Ps, giving them the speed they need for fusion. As the Ps accelerate, they collide with enough force to overcome their natural repulsion, fusing together and releasing energy. This is the heart of the fusion process. So next time you see a fusor, just think of a squash, a tomato, and some peas. It's a simple yet powerful way to understand a complex scientific phenomenon. It's a tasty way to understand nuclear fusion. And who knew that vegetables could be so educational? Thanks for watching. If you enjoyed this veggie-powered explanation, smash that like button and subscribe for more science made simple. Stay curious. And remember, science is all around us, even in our kitchens.